Well, hello, everybody.
Welcome.
Get this rolling. Turn this guy down.
hmm
33 is the lowest it goes. Okay. All right. Woo.
Yeah. So you said you're in Montana, right? Right now?
I am. I'm in Bozeman.
Yeah. How far is that from the office?
6.5 hours from Sturgis.
Okay. Okay.
So it's a trek, a
Yeah.
little bit of trek. So make sure my lab is working. There we go. So hello, folks. Welcome. We're just doing some last moment stuff.
Montana is nice. I've never been out that way. I'd like to get out there though.
Montana's a big state.
Is it?
Yeah.
Okay.
I think the reason why they call it the Big Sky State is because like you have mountains all over the place and
hmm
it kind of frames the sky in a way.
Okay.
Um, so it just feels big.
Yeah.
It's not like, if you're driving through like East or West Texas where it's just flat, like that's big, or a lot of parts in like Kansas that just goes for corn
Yeah.
forever, or Nebraska. But like when you can see off way in the distance and see mountains coming up, it gives you a much better idea, the perspective of the distance you're dealing with. And I think that's part of the reason. And also there's more like different mountain ranges where like you go to Colorado, it's like you go up to the mountains and boom, you're in them, right? You just see
Yeah.
them off the distance and they come up, but you'll have like framing. So you'll have like, Rocky Mountains and then you'll have the Bridgers over here and it'll be kind of framing the valley in a way, I guess. So, but it's beautiful up here and Bozeman is great. It's a nice little town. It's a very weird town. It's kind of a small city, but it
hmm
has like the traffic problems of a major city because there's so many people
Yeah.
in this area as well for tourism and stuff. Got people chit-chatting.
Yeah. Alberta, Canada. I'd like
Got
to
to
get
get
out
up to
there too.
Alberta. Be awesome.
Yeah.
Yeah, Austin to El Paso now, because there's nothing in that desert forever. Beautiful, but yeah, it's kind of the same thing. My wife and I, we were driving through, and I can't remember, I think it's Beaver, Utah. We stopped and like the middle of the night, we got a hotel room, and it was very much like something out of, some Hollywood movie set in the middle of the desert, like hotel in the middle of nowhere. Like, oh
hmm
my God, we're gonna be attacked by demons at any point now. Yo, I think we're all set up. All right. Good morning. Got Team Simply Cyber here. Shout out to all of the Simply Cyber people. Daryl, we need to add a note. We should just add Jerry and Simply Cyber as like one of our sponsors, just because they're
Just
so much
because.
fun.
Yeah. Right.
Would I bring an EV on those trips? So between it's funny, there was an article about this. They were talking about how EVs are like it's getting easier and easier to drive across the country these days because there's more and more charge stations. And it was a really good article. They're talking about thousands of them going up all over the place. The best ones by far are the Tesla superchargers, and you can run your supercharger on like a Tesla vehicle and a non-Tesla vehicle. So we have a Rivian and we have a Chevy EV as well. So we were driving, and in this article, it says, however, there are still charging deserts in America. It said between Gillette and Billings is like 275 miles. and there's like no charging stations for anything other than Teslas. There's a Tesla in
Mm.
Buffalo. It's like, God damn it. That's the route that we drive all the time between Spearfish and Bozeman, is that desert. But the EV that we have, the Chevy, it can make it just fine. So whenever we drive through there, one of the things is keep your speed low. Don't try to go 85 or 90 miles an hour, and you'll be just fine. But when we got, I think when we completed that trek, we still had like 150 miles of range. And
Mm.
you can go to a good supercharger. It charges really, really, really fast. Like you plug in and you're at 80% to get to Big Timber or wherever in less than 30 minutes. And a lot of them are like
Oh,
next to
okay.
coffee shops or places that are pretty good.
Yeah, 30 minutes. That's not bad at all.
Yeah, you mentioned Cheyenne to Yellowstone. It depends on how you go to Yellowstone. There's a Rivian charger, oddly enough, I want to say, God, where is it? There's a RAN charger in between there, and you can charge in Casper, Wyoming. You can charge there. So you can go from Cheyenne to Casper, from Casper up to another one of that as well. So no, it's not that big of a deal. You just got to make sure that you have enough charge, and it's not. Once again, don't push your speed, and you'll be just fine. The Chevy has the Super Cruise, where we can do hands-free driving
Mm.
and just sit back and chill and vibe, and it's pretty good. But right now, Daryl, I
Yeah,
think it's time. I think it's
it
time to
is time. Let's go.
let's do it. All right, everybody. So when we left, we were doing a lab. We were just getting started on the lab, and I was going to start with the walkthrough of doing password cracking with Hashcat. So I'm going to go through and just follow the instructions. We're going to disable antivirus on the system. Once again, the goal of this isn't, you know, we have people that take this class and are like, oh my God, we're shutting off AV and this is cheating. Attackers won't do that. Remember, if you take the entire attack methodology and you break it up into chunks, we're kind of addressing each of those chunks individually and also trying to come up with a class that's all about bypassing AV. While fun, can be somewhat problematic as well. So we've got our Kali terminal open. I've made it a larger font size. There we go. So becoming root, we're going to delete the pot file, even though I don't think it's on the system. No, it deleted it. It's just a good habit to delete that file or copy it off to a backup file. Then we're going to CD into the password cracking directory. And in this directory, we have three different types of passwords. We have the MD5 passwords, we have the password.list, which is our text, our dictionary, and then sam.txt. So we actually, believe it or not, have three different types of passwords represented here. MD5 is still used by a lot of databases and web servers, unfortunately. And then the sam.txt, if I less that out, let's do sam.txt. You see that there's actually two different types of hashes represented in this file. So we have ADHD, that is the user account. The RID is 100. That means it's the first manually created account on the system. And then we have this AAD3B4. This is the landman password hash. It's actually empty, believe it or not. Landman is notoriously weak password hashing algorithm. Very, very, very bad stuff. Like you really shouldn't use Landman at all. But I know it's blank because if you look at anybody that has a blank Landman password hash, it always begins with AAD3B435B514040, and then it repeats. And the reason why it repeats is Landman isn't hashing the entire password. What it's doing is it's breaking the password into two 7-character strings as represented in two halves that you see here, starting with AA and ending with EE. And then it converts them into uppercase, and then it does DES encryption, where it encrypts the string KGS exclamation point at pound prompt $ with your password as a key. So that's how that works. An incredibly insecure password hashing algorithm. So the vast majority of Windows systems, they still have it, but it's blank. It's kind of a placeholder that's represented right there. Then the next one is the NT hash. Now, NT is much better. NT is a straight MD4 hash of the password. So upper, lowercase, and length are preserved with it. So that's what that hash looks like. If we less out the MD5, these are just straight MD5 hashes. If you take this to like crackstation.net, you can do a bunch of things and it'll crack those relatively easily. But the goal of this lab is for us to use Hashcat to crack these password hashes. So we're going to go ahead and run this one. And I want to go through it. So we have hashcat right here. We have A0. Okay. What does that mean? So A0 means it is a straight crack mode. Okay. So it's just going to do the hash in the dictionary. Okay. That's good for us there. We have M0. See if we can see that. Like, what is the hash type that we're going to crack? And it says that we're cracking zero. And zero, if I can find it, is MD5. It's probably up top somewhere. But zero over here, the type of hashing algorithm, you have like MS SQL, you have the Oracle, Sybase, you have EAP server, you have all these, but zero represents straight MD5, which I'm going to be a little bit freaked out if it's not here. Huh, that's really, really bizarre. I guarantee you I'm just missing it. I can almost guarantee you. Yep, that's the same cheat sheet that's in the resources. So we're saying we're going to crack using MD5, and we're going to use a rule file that's user share hashcat rules. We're going to do least speak substitutions, which means it's going to take O's and turn them into zeros, L's turn them into ones, and so on for that. And then we're going to give it the md5.txt, and then the dictionary that we're going to use is password.list, which is the default dictionary that comes with John the Ripper. So it's kicking off. We're going to see it get a whole bunch of stuff here in just a couple of seconds, and then it's going to start cracking, and it takes a few moments for it to crack. But the main hashes are you have the M0, which is MD5, and then the other one that we're going to be looking at is Landman and NTLM. We're actually going to be cracking NTLM here in just a couple of seconds. Now, oddly enough, the only two hashing algorithms that Microsoft uses are Landman and NTLM. Those are stored in domain controller on a file called ntds.dit, and you can extract that out using volume shadow copy style techniques. So if you see people saying, well, we're going to crack net NTLM v2 or net NTLM v1 password hashes, that's not a thing. Those are authentication protocols. So the first thing you do is you reverse the authentication protocols to get the hashes, then you crack those hashes as well. So there we go. It went through and it cracked our passwords, and we have the hash. This one was Peanuts. The next one was Tiger2. Then we had Swordfish, Thrasher, Love123, and Cross Country. So that is cracking MD5 password hashes. Now, the next thing that we're going to do, if you ever want to, you can do show again, and it'll actually show you what passwords it cracked. And then we're going to crack the NT password hashes like so. Went a lot faster to establish. Now, this is kind of weird. Whenever I set this up, one of the reasons why Hashcat works so well is because it uses GPUs. So if you're following anything that's going on in the world today, like GPUs originally were created for video games, but they were used for Bitcoin mining, password cracking, and also AI algorithms. So why did GPUs work so well for these things? By the way, it cracked it. So you can see this is freedom. Dun, 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 dun. And then we have blank. And then we have 8675309, password, vendor, and rabbit1. Rabbit is good, rabbit is wise. So those are the passwords that we just cracked. Now, why is it that Hashcat works so well? Well, the main reason why it works so incredibly well is because, well, let's go back in time. I'm going to go, let's do this. Let's go back in time to, so this is one of my favorite games of all time. It's MechWarrior 1. Okay. And you can see the graphics were pretty primitive for their time. Actually, they were amazing for their time. But this is one of those video games, if I get dropped in, like right now, I could play this game and crush it, by the way. But this particular game, if you look at the graphics, they're very, very, very basic and very angular. Now, this game predates modern GPUs. Right. So the graphics, the gameplay, the logic, the AI for the bots, everything was completely rendered by the CPU. That means every single pixel that you see had to be calculated what it was and where it was going to be represented on the screen. Now, as time went on, Crescent Hawk's interception was great as well. Inception, by the way, were you able to get what was the name of? I think it was a wasp. You could get it if you played it just right. You could keep your training mech, and then you just dominated for the rest of the game. Really good game. So what they found out with graphic processing units, we're talking about like old ATI or Voodoo cards or things like that, was instead of having the graphical processing being done by your CPU, which was very, very, very fast, but still a single CPU, the idea was, what if we had multiple CPUs, small little CPUs, doing parallel programming and math algorithms, right? So this gets into floating point arithmetic. So if you're looking at the calculation of polygons, you're looking at the calculation of shapes, what you're doing is you're taking one math algorithm and you're doing it multiple times for what you see on the screen here. And if you think about modern video games where they're calculating like wind going through someone's hair, wind going through like light filtering through leaves, it's taking mathematical algorithms and it's doing them in massive parallel. And that's what your GPU is. Your GPU is not a single CPU. Your GPU literally has thousands of little baby CPUs that break up that mathematical work across all of them and they do it in parallel. So when you're trying to crack passwords, you're doing the same thing. You're doing one mathematical algorithm, but you're repeating it in massive parallel across multiple GPUs. And that's what Hashcat does. So all of this is all tied together with massive parallel processing of many GPUs, thousands of them, whether you're talking about mining for Bitcoin, same thing. Graphics on a video game, same thing. Processing and training algorithms for AI, same thing. So that's why NVIDIA has like, trying to get what is the current price for a A100? Let's see. So right here, the A100 GPUs, which you don't even use for video games, by the way, you just don't. They range from 8,000 to 12,000 for 40 gig units and 13 to 20,000 for 80 gig units, which is actually getting down in price a little bit. And you can also rent them as well. So when you're looking at these GPUs, this got to the point where there are so many organizations buying them, using them for AI, using them for Bitcoin, using them for all these different things, that it's driven the price up dramatically on these things, which actually makes it kind of difficult for like BHIS and other companies that use graphical processing units for password cracking and what they do. So that's a little bit of background on what you just did in that lab. So hopefully it helps make a little bit more sense. There's other ways that we can get password hashes, though, rather than breaking into computer system. We can exploit something called link local multicast name resolution, Microsoft, or not Microsoft, MDNS, and NetBIOS name service. The way that these protocols work is if your system is unable to resolve something through DNS, it'll send out a broadcast packet to every system on the network, asking them if they have a cached answer for that particular system. So if I'm trying to go to GoOggle, let's say I type in too many O's, if I do that, well, that's not a real system and DNS is going to fail. And then you'll see an LLM&R packet trying to resolve google.com. And you can attack that by giving them the quote unquote wrong answer. This works incredibly well. We used to have a lab, it's one of my favorite labs in this particular class, but it went away because we had to virtualize. And Amazon does not allow systems to communicate on layer two. But on regular networks, works just fine, all good in the hood. Now, this tool is so effective that some of its features are disabled. So Laurent, when they set this up right here, right at the bottom, you can say WPAD, Web Proxy Auto Detect, is set to off automatically. Now, what is Web Proxy Auto Detect and why is it set to off? Well, Web Proxy Auto Detection is literally what it says on the can. When your system starts up or you're on Android or any of those things, if it's running the WPAD service, it'll automatically query the network, and I'm not making this up, for a computer with the name WPAD. That's it. The thought process was, We just name a system WPAD. All of the systems on the network will come to that computer and get a pack file. A pack file is a proxy auto config file, And this file tells your browser how to go to the proxy, whether or not you have to authenticate to get to the internet. The only security is the name of the system, WPAD. So if you gain access to a network and you name a computer WPAD, all of the computers that have WPAD enabled will come to you to get their pack file, and you can lie to them and route them through Responder, where it has all of these services, HTTP, HTTPS, SMB, Kerberos, SQL, FTP, IMAP, asking your system to authenticate to it. And then it'll intercept those passwords and or password hashes. Now, I mentioned at the beginning of this, that is disabled by default. Does anyone want to take a wild, crazy guess as to why WPAD is disabled by default? Anyone? Bueller? There's a little bit of delay on the Discords. It's almost like Discord is logging everything that we're doing, which is kind of a scary thought. Oops, let me scroll down. What's that? There we go. But yeah, the reason why it's disabled is because it works too well. It works too well. We've had testers turn this on, and it's in our usage documents now at BHIS. It's like big, bold, do not turn this on under any circumstances. It's going to kill you and it's going to hurt the whole time. But the problem is on a network, let's say 100,000 nodes on it. If you have a system that all of a sudden pops up and it's like, hi, everybody, I'm WPAD, and I'm now the proxy. You now have 100,000 systems that are sending all of their traffic through you, and you will crash the network going out to the internet. So this is disabled by default for a very good reason. Now, if we're trying to do password spraying attacks, which we started with this password section, we did two. We did a password spraying attacks with Bo's tool, which is domain password spray. And then we did another one externally by using the SMB login capability of Metasploit. Okay. Now, you stay ready, or Mike Felch, who used to work at BHIS and is now over at TrustedSec. This particular tool allows you to do password spraying through AWS Lambda for IP rotation. So it basically means that you're not scanning and not doing a password attack from your direct computer system, but rather you're bouncing it off of Amazon Lambda service to attack another service like Microsoft 365. Also, you can use tools like EvilGenX or EvilJinx that allows you to intercept not just the user ID and the password, but it also allows you to intercept the two-factor authentication and the session identifier. So this is a little bit more of a setup and a little bit more difficult setup than just a traditional spear phishing attack, but it is still very effective, and there are still tools that are out there that allow you to bypass 2FA. The other thing you can do is device code phishing, where you can take advantage of how device code authentication works and have the device code authentication work against an app that you have created for cloud services as well. Now, earlier yesterday, some people were talking about password managers, and there's a number of them. Password managers like LastPass got into a wee bit of trouble when they were compromised, and also people found out that they were using AES, and they were using electronic codebook mode. Now, I spent a good portion of yesterday morning kind of crapping on different modes of like AES and how that works. But the problem with AES electronic codebook mode is whenever you encrypt a file, let's say something like a password, it's going to use the exact same key for every single block. That's because AES is a block mode cipher. And the problem with using the exact same key is if you crack that key, well, the world's your oyster, right? It also was using that exact same key for every password you were using. So it was using AES electronic codebook mode and using the same key for every password in your store. So it became easy for you to see which passwords were being reused. Those would be the most important ones, and you could crack those passwords. That's bad. That, and admittedly, the fact that LastPass was hacked is kind of a problem as well. We also have one login. You also have secret server. There's a number of different services that are out there for password managers. And really, people get into long, in-depth conversations about which password manager is the best. And generally, I take that as a cue to not hang out with those people. I'm old. I'm sorry, Brian, if you're here, but I'm old, I'm crusty, and there are far better things I can do with my time than sit around arguing about which password manager is the best. Rather, I just encourage people to use them. That's the one thing that I'm asking. Privileged identity management. So we get into that problem of reusing passwords. And trust me, it is absolutely a problem. No question about that. When you're dealing with organizations, it used to be that they would set the same local administrator password on every single computer system, which is bad. You shouldn't do that because if I gain access to one system and then I run hash dump on that computer system, I can then use a pass the hash technique to attack every system, which reminds me, Daryl, could you do me a favor? Could you send me an email and say create a pass the hash lab? I think Daryl's hanging out doing stuff. Sometimes he scurries
Yep,
away,
I
gets the
got you. What do you
password.
need? Sorry, I
Yeah, can
was
you
just.
shoot me an email, create a pass the hash lab?
Yep.
Thank you, sir. And once I get that password hash, it's as good as the password. Um, how do you guys feel about a detour? Should we do a detour? I think we should. Let's do it. How does that sound? All right, let's do a detour. So I'm going to do a lab and you can follow along if you want, or you can do it later if you want, or not do it. I really just, it's up to you. Um, let's do, let's build on the password spraying lab. How does that sound? And then what I'm going to do is I'll paste in the commands at the end of this lab so you can do what I did, barring that this works. All right, so let's do it. All right, so I'm going to kill this. I'm going to go like that. And then I'm going to start up. I've already killed that. I'm going to get the IP address of my Windows computer system. And the thing I'm going to try to show you is I've got a question for you all. Why is Telnet bad? Like you have people all the time, they're like, shouldn't use Telnet, shouldn't use FTP. It's bad. You guys can type in your answers when you feel equipped to do so. There we go. I'm moving fast, by the way, but I'm doing the external password spray lab. So all right. So what we are doing is we are prepping the system to do we're going to log in, right? And then I'm going to show you something about passwords on Windows computer systems. Here we go. All righty. And then we're going to become root on Kali, which I think I already did. Yeah, we did. And then I'm going to double get the user list. And we're going to use this specifically in Metasploit. And then, like I said, I'm going to copy and paste. It's not going to have full screenshots at this time, but I'm going to copy and paste in the commands that I ran because I think this lab would be a badass lab to demonstrate pass the hash. I think everybody at some point in their life should do pass the hash before they die. I think it's a good thing for everyone. All right, so we're going to start up MSF Console here in a couple of seconds whenever Metasploit starts. And what we're going to do is we're going to exploit a system with the password spray attack. We're going to break into that computer system. We are going to dump the password from that computer system. And then we're going to log in, not knowing what the password is. We're going to log in with the password hash. Okay. We're going to log in with the password hash rather than the password. I know it sounds like it's some elite stuff, but we can do it. We can do it together. So we're gonna do this. Alrighty. As I'm doing, anytime I do this stuff, it's always like, what were you thinking when you started doing this, John? That's kind of crazy. All right, so we're gonna do use auxiliary scanner SMB, like so. Then we're gonna set our R host to be our Windows computer system. You can call R host whatever you want, but honestly, it stands for remote host, right? So we're going to go ahead and I'm going to get that IP address is going to be 10.10.64.160, right? Then we're going to set the user file to be users.txt, like that. Then we're going to set the password to be winter 2025. Okay. There we go. And then we're going to, I'm not going to do any of that. And now we're going to run it. Now, it's going to attempt to authenticate to every single one of these user accounts. And if you remember, yesterday, Dennis was an administrator and he was running a password of winter 2025. Bad Dennis. You know nothing, Dennis. Sorry, I could do Jon Snow if I wanted, but I decided to do Dennis on this because, hey, it's fun. All right, so now I'm going to use a different module. I'm going to use exploit. We're going to use Windows as the operating system. SMB is the protocol. And then we're going to use PSExec. Now, PSExec is actually a tool that was created by Mark Rusanovich from Microsoft. Well, before it was NT internals, then sys internals, and then Microsoft bought them out. But we're going to use this as a exploit to gain access using built-in Windows protocols to break into the computer system. And it says we're defaulting to Windows Meterpreter Reverse TCP. I'm going to set the L host for the listening host to be ETH0 for my password. We're going to set the R host to be 10.10.64.160, like that. Do you know what I need? I need a space. Let's do that space, 10.10.64.160. We're going to set the SMB user. We're going to set that to Dennis. Dennis! And we're going to set the password. We're going to set that password for the Dennis account. We're going to set it to winter 2025. All right. Now, exploit. All right, so now we're going to authenticate to that remote computer system as Dennis. Dennis is an administrator. As soon as we authenticate to that system, it's going to start up a new service that's going to reach back to our Linux computer system, grab Metasploit, inject it directly into memory on that computer system as a stage, and then we're going to get full access. After it's done getting us full access, it's going to delete that service, delete the file that it loaded onto that computer system, so there's no evidence left behind, because that's the way you do crimes, boys and girls. All right, so I was now able to break into this computer system with the Dennis account. So now I'm going to do hash dump, and I'm going to dump the password hashes off of this computer system. And you can see we've got lots of password hashes, right? We generated 200 users. Now I know Dennis's password is winter, right? I know Dennis's password is winter 2025. I didn't change the administrator's password. So watch this. I can take the administrator's password right here and I can copy it, right? I'm going to copy that into Notepad. Like so. I'm going to make this bigger, longer. There we go. That looks good. So this is the administrator's password. And to show you that I'm not trying to trick you, I'm going to close this section. I'm going to do exit. There we go. Shut down that. Now I'm going to set the SMB. We're going to keep the password to winter, but I'm going to set the SMB user to administrator. Like so. Now I'm going to type exploit. Now the administrator's password is not winter 2025. We're going to get an error. So you can see right here, it says the exploit failed, no access, protocol exception, log on failure. I don't know the admin password. I don't. Yep. I just don't know what his password is. It's randomly generated whenever I create this VM. In other labs, I have you change it. I'm not going to do that. But rather what I'm going to do is show you that I don't have to know what the password is. I don't even have to crack the password on a Windows computer system, because this is the trick. The password hash is the password. I know that that sounds wild, but hear me out. Whenever you authenticate, you send a request, an authentication request to a Windows computer system. It responds back with a 16-byte challenge as part of net NTLM v2. That challenge is sent clear text. You take your password hash, and only your password hash, and it wraps the password hash with that challenge and scrambles it. And then it transmits it back to the system, which takes that challenge, reverses it, pulls the password hash, and does a simple password hash comparison to see if you successfully authenticated. In short, your actual password isn't used in this entire process. Your password hash is sent. So Windows systems treat the password hash as the password, and all of the things I just described are sent clear text. So we can see that challenge, we can see the response, we've reverse engineered that challenge and response so we can pull out the password and we can crack it. But I don't even need to, because if I'm on that box, I can set the SMB pass to be the password hash. So if I go here in the password hash, like this, I copy it, I set that to the password, and then I do exploit. As far as Windows is concerned, it doesn't care. You've just submitted a valid password hash, does a comparison, checks to make sure that you're the administrator, and boom, you're now in the system. How cool is that? I want to see if they added in a history command. Nope, they don't have a history command. So that is the setup. And during the break, I will take all the commands that I ran and I will add it to the bottom of this lab and I will expand this as well. Why can't we not change it to send the full encrypted password? Because it would break all Windows computer systems unilaterally across the entire planet. All authentication would break. Kerberos, different, but you still have pre-Kerberos authentication. And then you have the tokens, and you can use tools like Mimikatz to extract and do duplication on that as well. It sounds like a good reason to do it. Man, Roswell woke up this morning and chose anarchy. I dig that. All right. So that's why having randomized passwords as it relates to privileged identity management is important. Because if you use the exact same password for every single local administrator account or privileged account in your environment, if the attackers gain access to that hash, they can reuse it using pass the hash. It could even be like supercalifragilisticexpialidocious, even though the sound of it is somewhat quite atrocious. Exclamation point one, capital A. Meeting those password complexity requirements are important. And we can still just use pass the hash for that. So randomizing these passwords is really incredibly important for everybody to do it. So we already did the hashcat, we already did the spraying, and now we're going to move on to egress traffic analysis, and we're going to have a lab on that here in just a moment, which I think is fun. So does anybody have any questions about that section before we move on to egress traffic analysis? Supercalifragilisticexpialidocious, even though the sound of it is somewhat quite atrocious. Uh, we got a bunch of people. We got Iron Monkus resonating. We got questions coming in, which is cool. That was awesome. Thank you. Thank you. Appreciate that. All right. Several people are now typing. That is actually a really good password. That's awesome. How can you catch the challenge via network capture? One, if you're on the network, you can do ARP cache poisoning to redirect the traffic to your system. But remember, we were talking about link local multicast name resolution. Let's go back to these slides. If you look at link local multicast name resolution, SMB server is there. So if somebody is running WPAD or LLMNR or NetBIOS name service, we can intercept that authentication and grab their password hash on that as well. Okay, so single sign-on is good, but you got to understand single sign-on is good for protection of that initial authentication. Once the attacker is on the inside of the network, everything gets really interesting very, very, very quickly. There's a number of attack methodologies that we can use on that as well. Oh, I don't know if it's going to take a long time to crack. It's now in my dictionary. So, all right. All right, so let's get to egress traffic analysis, and then let's get into some labs. How does that sound? Right? All right. So if we're looking at MITRE and egress traffic, these are the predominant columns that we are interested. Command and control and data exfiltration. So what we want to do is we want to take advantage of how we can actually remove these as possible channels for an attacker to gain access to your environment. And I just realized I needed to check something this morning and I didn't. Let me check it now. We do have it. You guys want to see the new version of AC Hunter? Of course you do. All right. Awesome. Awesome. Very cool. Let's see if it works. We did it with 20 students in Denver. Now we're going to kick it up a lot more. So the need for visibility and doing some mathematics becomes really important for us at this particular point, right? Basic alerting is not enough, and doing simple signature-based detection isn't enough because we don't have context for what's actually going on. We need to further identify gaps in the endpoint coverage, and this is one of those weird areas where Gartner and I actually agree with each other, where you need to have host-based identification and you need to have network-based identification working together synergistically and leveraging each other to basically smooth over any discrepancies between the two or failings. And that's a lot of consultant speak in a very short period of time. All right. So one of the things we can do is we can look at net flow traffic. Right? We can look at net flow traffic. Now, this was a standard that was created by Cisco, which means it is, in fact, a standard. This also means that a lot of other companies were like, well, we're not going to do Cisco. And they became petulant children and they tried to create their own flow analysis. So you had like S flow and N flow and K flow, Q flow, all these different vendors came up with their own flows that they were going to watch for. And it became kind of a nightmare to try to look for it because it was all inconsistent in the way it actually worked. But at its heart, it's traffic statistics. What is the connection? How long was the connection? How much data was transferred between two systems, right? You have an exporter, that would be the device that's capturing the data. You have an importer, that would be where it's receiving it, and then an analysis engine for giving you some information on what's going on. And a lot of companies created their own, and it was a problem. We are going to be using Zeek in this class because Zeek is awesome. It is really incredibly fast, has an incredibly large user base, tons of support, very strong consistency in how it does timestamping of the actual connections. And many devices handle timestamps in different ways, generates tons of logs. And really what we're trying to do here, just to be completely blunt, is we're getting away from log-based detection, or sorry, signature-based detection, and we're doing analytics-based detection instead, right? There's a lot of ways that an attacker can obfuscate their code and make it difficult for you to see it in the network traffic, all the way down to just simply using TLS and SSL to encode things as well. Now, what we're getting at though is we're truly trying to get into hunt teaming, right? We want to actively look for advanced attackers. Honestly, in some fashion or another, you've probably been compromised. And seriously, if an attacker like BHIS or any of these other companies can bypass ADS, AV, and IPS, probably the attackers can too. So we need some type of intelligent analysis of all of our data sources at our disposal. So there's lots of logs. But before we get too crazy, we want to articulate the problem. So the first lab that we are going to do is the advanced C2 lab right here. Where is it? I've got to find it. No, it's all the way down here. It is advanced C2. It's actually down in cyber deception. I'm going to take this and I'm going to throw it into Discord just so you guys have it. There we go. So this is the lab that we are going to be working on. We're going to articulate the problem to start this out. So you're going to open up a Kali terminal. You're going to CD into the opt covert directory. Then you're going to run TCP dump, don't resolve any names, and show us the ASCII. We're going to read in covert C2, and then you're going to see the data. You hit spacebar a couple of times, you'll see some data coming through. We're going to be focusing on view state parameter data, and it should look like this. And you're going to be looking for this underscore underscore view state parameter, which is where our C2 is. Now, for the record, there's no TLS SSL here, chat. There's no TLS SSL. We're just showing you how the attackers can use steganography techniques to hide what they're doing. Then we're going to look at some basic beaconing. This is going to lead into the next section. We're going to go to the 13th byte offset in the TCP header starting at 0, and we're going to check to see if it's a value of 2, which means SYN packets. Then we're going to look for the hidden form fields. So this is a beacon, this is a beacon, this is a beacon, this is data being transferred right there. And then you're going to go through and decode it. Now, you can do it in Python. You can also do it in a really cool tool called CyberChef. Do CyberChef, and I'm going to share this link as well. There you go. And you can input your base 64 and then go from base 64 in your recipe and it'll decode it for you. All right. So really, really basic stuff that we have there. Let me close this out. And this will be the quick lab. This lab's only going to take us about 15 minutes. It's very, very fast, copy and paste, and it's going to set the stage for what we're going to talk about next, which is Rita and AC Hunter. All right, so let's get rolling. I will see you on the other side of this 15-minute lab. All right, and we are back. All right, so let's get started with this lab. And I know my screen is live and everyone can see my content. Thank you, Zoom. So we're going to CD into the opt covert directory. Don't need to be root for this because we're just reading the data in. And then we're going to run TCP dump and we're just going to look at the PCAP data itself. All right, so this is just the raw PCAP data. And if I go down here, right here in this view state parameter, this is the backdoor, right? Now, the reason why we chose view state or underscore underscore view state is because it's an ASP.NET server parameter that is used to track session information, right? So it's variable in its data content and it's variable in its length. So if we have a quote unquote pseudo randomized value that is variable in its length and its data content, trying to write a signature for something like that is exceedingly difficult to do. All right. So let's see if we can look at the problem a little bit cleaner on this. I can focus just on the SYN packets, and this leads into where we're headed in just a second, where we're going to be focusing on the behavior of the network connections rather than the signature content of the network connections. So we're going to be looking at the data size, we're going to be looking at the beaconing, and you can see that we have a beacon that's roughly like 30 seconds here. So we have 38, 8, and then 39. So that's a good indication that we have a beacon going on right here. So now we're going to look at just those hidden form fields, right? So if I do this, you can see that we have our EYJ, 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 but this one right here is much, much, much longer. And that is our encoded data. That is base 64 encoded. Not like super heavy encryption by any stretch of the imagination, but it is a type of encoding, right? So if I paste that in here, and I base 64 decode it. And the question is, how do I know it's base 64? If you look at the character set that's being used, upper, lowercase, and numeric, and then it ends in a like a number of quotes, some or equal signs, sometimes that is used for padding. It's usually base 64. And then down here is the decoded aspect of it. So the point of all of this is trying to write a signature for every possible different type of backdoor that exists is actually really incredibly hard to do, right? Especially if we're dealing with any type of steganography or dealing with any type of encryption or any of those different things makes it hard to detect. And that's where RITA comes in, Real Intelligence Threat Analytics. And this is designed to look at patterns in the network traffic itself, specifically looking for beacons. It also does some denialist checking, DNS view, long connections, and all of it's for free at github.com, ActiveCM, and RITA. Now, just a couple of things that it looks at is it's trying to identify clusters of consistency. All right. So I want you all to imagine, I don't know, let's say hypothetically, a conversation with a small child. Some of you have children, some of you have been around children. I know it's happened to all of us at some point. But we'll get through it. We'll persevere together. Now, I want you to imagine a small child having a conversation with a parent and they go, mom, 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 or dad, 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 dad. That is a beacon. It has a really tight interval. It has a really tight data size, and its connection time, getting a little wishy-washy on that, is really consistent as well. But it's not perfect, right? So even though like human beings trying to keep beats and doing things like that is really, really, really super consistent, it's not going to be perfect. So the closer you get to the center is the closer you get to perfection in this inverse flux capacitor that I have up on my screen. The closer you get to that center, the closer you get to perfection in that beacon, but you're never quite there. You're going to have this cluster of consistency. And when you're using algorithms like k-means clustering, which is one of the algorithms that is used for this. So if I do k-means clustering, right? Go to the Wikipedia. This is just one algorithm that is looking for clustering of data sets. Now, the types of data sets that it's looking for will change, but it's going to look for that consistency in those data sets. And I always like to joke, as you can tell, This algorithm's pretty much self-explanatory. Another algorithm that we use is medium or like medium MADMOM, medium average distribution of the mean, which is another tool that we use as well. We can also look at long connections. How long was this established? And for long connections, I don't want you to think of one established connection that's running for 24 hours. I want you to think instead of like a string of spaghetti, dried spaghetti, mom spaghetti, because there's vomit on his sweater already. So you take this long string of dry spaghetti and you break it. It's going to break into a variety of different sizes. Some of those are going to be longer than others. Some of those will be really teeny tiny and short. There's going to be variation. But when you reassemble them, it comes back to a full string of spaghetti, which is representing 24 hours. So when we're looking at these connections, you may have some long connections, some short connections, quick bursty connections. But when we stick them all together, we see that they're communicating the two systems. The IP addresses are communicating with each other consistently. We can look at beacons, and that gets to that consistency and that heartbeat to try to identify that beaconing backdoor data. And over here is the value. So one is a perfect beacon. More importantly, we have a value of one for a perfect beacon that has 108,000 connections at a perfect beacon. That means this is non-human connection data that we have on this. Okay. So this next one is 20,000. So we would want to focus on those beacons for doing analysis. Now we're going to take a beat and we're going to take a break and a lab, and then we're going to come back and we're going to talk about this a little bit more. The lab that we're going to do, God help me, is AC Hunter 2. All right. So AC Hunter 2 is the new AC Hunter that we have in the cloud for everybody. We did it with 20 students. We're going to try it again. I'm going to make sure that it's actually running first, which is probably a good idea. We're going to go ahead and click proceed because we know it's unsafe. We're willing to accept the danger. And then we are going to log in with the creds demo at acm.re, right? And then we're going to put in the password of threat hunt at mile high. Fingers crossed. We're going to log in. And this is AC Hunter. Okay. Now, the lab actually goes through and kind of explains how to gain access to different data sets and look at what's going on at the different data sets. Like this is the DNS-Cat2 data set. This is XenoRat's data set, Asyncrat's data set. And you're going to be going through these data sets and answering questions at the bottom. All right. The question is in the Asyncrat data set, what is the connection interval for this IP address? What is the dispersion? What can the dispersion tell us? XenoRat, the connection interval, what is the different? How is that different than the Asyncrat C2? For DNSCat, which domain has the highest lookup count? Who is doing the lookups? And what does the DNS lookups look like? And what time data set? What is the fully qualified domain name for the C2 server? What does the interval look like? Why would they use a domain like this? And then for the FiStack 2 data set, we have issue with MIME data. Now, MIME data is what defines the data types. And then what is the issue with the user agent strings? And if you hover over the little eyes over here, so if we go into any of these, and if you have something, let me go to Asyncrat right here. If we go into any of these, you can see some data associated with it. And you can hover where you have any eyes. And I don't have any eyes right now. Any right. But look for the little eyes and then hover over them. So these are the questions you're going to answer with these guys. So with that, this lab and the break is going to take us 40 minutes. So we will resume in 40 minutes. So Daryl, are we ready to kick out the jams? And by the way, I want you guys all to work together and post your answers inside of Discord on this. Okay. And if it stops working, let me know immediately. I'll be watching. I'm hoping it works just fine. We're slowly working our way up to having more and more people using it. It seems to be working really well so far. It is pretty. All right, let's kick it off. Let's do it. 40 minutes on the clock. Let's go. Right. So let's go through this really quick. So we're going to go through each of the questions. So the async rat connection interval for the IP address that ends in 36. So I need to go here. Let me pull this over. There we go. Let's go to async rat and right here, this one. So if we open this one up, the question was, what do we have here? What is the connection interval for 192.168.10.136? If we look at that, we have our connection dispersion. This is the interval. And you can see that we have this weird kind of dispersion going on. So if you remember, I was talking about the boom, 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 that heartbeat, mom, 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 mom. That's the dispersion. And the interesting thing about this particular dispersion is it isn't just 7 seconds. It isn't just 6 seconds. It's actually kind of dispersed for dispersion. So we have 5, 6, 7, 8, 5, 6, 7, 8. But this is a dispersion with jitter. So there's a little bit of jitter going on with this connection dispersion. Also, the data dispersion is really, really, really strong, right? We have this, what is it? Data size between 1.4K and 1.6K, and we have 13,000 beacons with that. And if we look at our connection over time, we have a really high persistence in that as well. And any of these you can click on and you can see it in more detail, and you can kind of move around in it for getting a better view of the data sizes per hour. Now, the reason why we do this connections over time and we break it out by hour is they want you to think every single one of the hours in a day is like a bucket, right? And when you have a beacon, that beacon's going to fill up that bucket with so many connections per hour. So even if there's randomization, you're going to see that kind of level out in the amount of connections per hour. So even though we have some dispersion here, roughly we're getting 558, 559 connections per hour. So that's the answers for that one. For Zenorat, let's go ahead and let's open up Zenorat, which is kind of a cool name for backdoor, by the way. It asks, what is the connection interval for the one that ends in 75? Right now, this one's different, right? This is a different backdoor. So wait a minute, did I get to load the right one? 172.208. There we go. Now, this particular connection is interesting because it's just one connection, right? It's not a whole bunch of connections, right? We don't even have like dispersion. It's just one solid connection that's transmitting 7 meg of data. So the reason why this one is interesting is there's very low connection counts and a high amount of data that's being transmitted here. Now, this particular backdoor, it doesn't like break up its connections and beacon. It establishes a solid connection and it just persists over time, right? So we have one connection right here over time, and it stayed up for a long time on that as well. So it's kind of showing you the difference between the connection intervals where it's broken up and we have thousands of connections versus very few connections with a high amount of data that is being sent through on that. DNS Cat 2, let's go ahead and load that data set up. Here we go, this r-1x.com. Now, this is interesting. This is what we call a DNS backdoor, right? And it says what domain has the most lookups, and you can see that r-1x.com has 62,000 lookups, right? That's kind of crazy. Now, if we scroll down, I think one of the other questions we have for this one, who is doing the lookups, right? We know that that particular system is making the connections. The 192.168.88.2 is making the connections. That's the only system that's making any connections at all, which is kind of weird. And then the other thing is, if we look at the fully qualified domain name, do you see how these are randomized? Like we have these really strange randomized strings, right? Now, the reason why DNSCat 2 puts in these goofy randomized strings at the beginning of the domain for C2 is it is forcing a full established recursive lookup. Let me explain. So if I go to www.yahoo.com, my local resolver, my local DNS server, which is like my router at home or a domain controller at work, that local resolver is going to cache that answer. So it's not going to look it up every single time. It's going to cache that answer so it doesn't have to look it up every single time. But that quality of DNS is not a super great quality for persistence and having communication. So we wanted to do a lookup every single time. So what it does is it randomizes the fully qualified domain name at the beginning of DNS or is it dnsc.r-1x.com, puts in a randomized string. So it forces a full recursive lookup to establish that kind of circuit connection again and again and again. So the local DNS server, be it your router at home or your domain controller, never caches the answer. Right. So that's what a DNS backdoor looks like. What time data set? Let's go ahead and go to that. There we go. And we got the time server sync right here. And this one, it says, what's the interval look like? And why would an attacker use that? So we have a connection interval. We have 33,000 connections between 0 to 16 seconds and a little bit of variation on that to 51 to 1 minute. And then our data size is really, really super consistent as well with some slight variation. We have our connections over time. Once again, it all levels out, even if we're trying to incorporate some type of jitter. But the domain is important, right? So the domain is a domain that we've used, and the reason why it's here is because we no longer use it, because it tends to blend in, right? That domain, time server sync, for many people, it doesn't say www.evildomain.com. So people are like, that's probably not evil. I mean, what are you going to do, right? It's a time server, right? That's what this connection is. Because the attackers have the ability to create domains or take over quote unquote legitimate looking domains so that they can blend in with the traffic on their name. Firestack 2, we got the one that ends in 51. Let's go back to that. Right here, this one, it's in DigitalOcean. If I open this one, you can see that we have like this modifier error thing. It's saying MIME URI mismatch, right? Now, MIME is where it identifies what the type of data and what the type of connection is. And if we get a mismatch, that means that what it says it is and what it actually is different. So if we have that connection, we have the refer, we look at the source signatures, user H string, and we look at the responding MIME, it should be text. The URI is a bit different. If you hover over the I, it gives you a little bit more explanation. And it says a mismatch was found in the responding MIME type in the URI on the highlighted rows. So this is where a backdoor lies about what type of data is actually being transferred. And that is the new AC Hunter. Kind of excited about that. If you want to, there's some more labs you can play with. If you're like, this is awesome, you can go back to lab directory and you can go to Rita 2 right here. And Rita 2, I need to get you, I forgot, I need to get you the code for this. I'm going to stop sharing my screen. Just give me a second. Let's go to text edit. So this is a different VM that I'm getting you access to. New, that's not it. Let's go file, open recent. Free labs. This. Here we go. If you put in this code that I'm going to give you here in just a second in Discord, let me resume. If you use this code right here, this code is going to get you a new VM. All right. So brand new VM. This is for my network threat hunting class where we use Rita very heavily. I'll put this in resources as well. So you got it. All right. And let me show you what it looks like. So it's not as beautiful as like some of the VMs and stuff that we've been using. But if I go back here and you put in the activation code right there, Rita, it opens up this Rita version 5 lab. And if I go in and start that lab, it's basically an Ubuntu system. And it's giving you a bunch of labs you can play with, where you can get the instructions on how to look at the new version of Rita, look through the data sets. And the way that Rita looks and shows you this data is actually very similar to the AC Hunter. Rita is quickly becoming the kind of the home version of AC Hunter. So we've got a number of different data sets that you can look at, and it asks you questions associated with these particular data sets. But that is the RITA 2 data set, and you have access to we have access to the RITA VM, which I'm starting up right now, and I'll come back to that here in a couple of seconds. All right, so you kind of got exposed, right? Like we had the problem statement where we showed you, hey, the problem is attackers can use all kinds of different encoding to bypass standard signature-based detection. And yeah, that's absolutely an issue. And then we showed you a solution with AC Hunter on how we can actually look at the connection profiles for the data to make a determination as to whether or not this is non-human data. Now, you're going to find things that are other than malware, right? You're going to find these things. So TeamViewer is one of them. I have TeamViewer here, right? With TeamViewer, if I go to this, just give me a second. Naturally, it's going to give me a problem. There we go. Let's go ahead and connect to my, which is actually not in my basement anymore. But this is a remote system that I have at home. Conboot is the user ID. All right. So this is a system back home. And this is a TeamViewer session. Now, this is a backdoor. Okay. This is absolutely a backdoor. Is it malicious? That is the question. Is it malicious? Because it's not necessarily malicious, but it's absolutely something that an attacker could use to try and get persistence on your system using an RMM tool. Remote desktop is another example, right? We saw a hospital in Wyoming get compromised with this as well. Over here in the lower left-hand corner, you can see something that looks very similar to a land turtle because the picture is a land turtle. But we were doing analysis at a hospital, and they had to switch out all of their stuff from wireless to wired. And they had some machines that did not have Ethernet ports, but they had USB ports. So they were able to use USB to Ethernet adapters. Problem was, every one of these USB to Ethernet adapters had a micro Linux kernel in them that you could remotely manage from the vendor. Company or the hospital didn't know that was a thing. So they had all of these medical systems that were beaconing every day, every 5 minutes back home. Now, is that necessarily malicious? No, it's not. But is it something you should be aware of in your technology profile? Absolutely, it is. Not Petya, Nuance, they're the people that bought Dragon Naturally Speaking. They have this ability, if you have trouble with the dictation software, where they can remotely come in and manage your computer to fix it. And there was an attack against Nuance where they were able to take over those systems. So all of this isn't necessarily malware, but it is something that you want to be aware of, no question. Now, as I mentioned, the tool is named Rita. And Rita is a free tool, okay? And a little bit of backstory about Rita. If you'd like to know more about Rita, Rita is my mom. She passed away a number of years ago. And there's a Darknet Diaries episode. I can't remember the number. Somebody can pull it for me. That would be awesome. Where you can find out a whole bunch of stuff about my mom. My mom broke into a prison, which I thought was pretty cool. A lot of people thought it was pretty cool because it was pretty cool. And I talk about that story and how she did it and what she did, which was great. But when we were doing this, when we were writing this tool, we didn't have a name for it initially. And my mom was working in the same office. She was doing finance stuff for us, and she was working in the same office as a number of the developers. And she kind of became the unofficial mom for a lot of these developers. She would bring in food. She would take them out to lunch. Got to know them really, really, really well. And then they decided to name it RITA, Real Intelligence Threat Analytics, in honor of my mother. Right around this time, my mom was diagnosed with cancer, and she passed away from the cancer as well. And the story I like to tell whenever we talk about this is when we released RITA to the public, my mom was in her fight with cancer, and I remember we'd go down to Cancer Treatment Centers of America in Arizona. My dad was doing it more than anybody else. He was awesome. And I would go down a couple of times and help. And I went down, and I remember I was doing a webcast, much like this one. I was sitting in the hallway, doing the webcast in the hallway while she was taking a nap after chemo. And she came out and she sat down next to me and she answered questions about cancer and what she was doing and things like that. And she got to know the community. She got to know you all. And she asked me when we were done, she said, this is a tool that, we're giving away for free. Can we keep giving it away for free? And can we continue to try to give things away? Because this community has been so good to our family, right? So I work at BHIS. My brother works sales here at BHIS. My sister does a lot at BHIS. And of course, my wife is here. I have my kids, they do stuff. And she was like, can we make this tool free? Um, and we have 26 patents on what Rita does, and we will keep it free. We got the patents to protect us from being attacked by other large companies saying, well, you're doing our patents. So we just patented first and we're releasing the tool for free to the community. To give you an idea of the type of woman my mom was, um, I remember right before she passed, she called us over to the house and she was feeling really good, which I'm going to come back to in a couple of seconds. She was feeling really good and she was having trouble remembering her password. She had a couple of different work items that she needed to complete because she was working up right up to the end. One of the things you learn is a lot of people with terminal conditions, they don't want to sit around all day and talk about their condition. They actually want to do something to get outside of their headspace. And I remember she had me change the password and then she handed me the computer and she said, I'm done. I'm not going to need this anymore. And that was the last good day that she had. And I came to find out actually years later that she felt really, really, really good. And she was gone within 36 hours. And I found out that that's very common. Very, very common with people that are fighting a terminal illness to feel really good right before because it's basically your white blood cells are done. All the energy it's using to fight this, it just stops. So you get this burst of energy back and you pass away very shortly after that. But we have this and it's patented and it's meant to be shared with the community. And we kind of continue that whole kind of idea and ideals moving forward because the only way that we're going to get through this shit, honestly, if you're looking at all of the crap that we're dealing with in the world today, if we're looking at like AI and the mass unemployment that's coming through, if we're looking at economic uncertainty and all the things, is by working together. And by giving back to the community for BHIS, it's been great for us. And it's been very powerful for us at Black Hills Information Security as a marketing tool, but it also makes the world a better place. And that's what we're going to do. Now, I saw some things about us not being a cult. No, we're not a cult. However, I always like to say if we were a cult, we would only have 4 rules, right? If this was a cult, these are the 4 rules of the cult. Number 1, be nice to people. Number 2, be especially nice to the people that piss you off, the people that you're angry with. Number 3, I strongly recommend tipping well. And number 4, always wash your hands after going to the bathroom. Those are our 4 rules. All right. So when we're pulling down and analyzing this data, in order for Rita to process this data and AC Hunter to process this data, and Rita is truly the engine that drives AC Hunter, the best place to start is full PCAP data, right? If you get full PCAP data, any tool worth its salt can process that PCAP data and help you do analysis on that data. It's incredibly portable. Everything supports it. You do run into issues of data size, and encryption can cause issues as well. And there is a learning curve associated with it as well. Now, where you want to put Rita is pre-network address translation. We actually have a customer right now that put Rita over here on the other side of the firewall, and there's a lot of beacons. That's because every IP address is the firewall. So we need to be on the inside of the firewall to get what we call RFC 1918 IP addresses, or non-publicly routable private IP addresses from the inside of the network so we can see where people are going. So you need to be pre-network address translation. And there's a number of different devices out there. You have Gigamon, you have Corelight. A lot of these are plug and play. They're very expensive. But one of the questions that we ask all the time, customers, they're like, well, we'll just build it. How much is your time worth, right? And having these tools just be able to plug in and let them go is incredibly powerful for companies to save them a lot of time so they can get to actually doing their jobs rather than building servers. And by the way, trying to build a dedicated packet capture device, relatively easy, up to about 10 gigabits per second. Once you get past 10 gigabits per second, you're getting into specialized network cards and you're getting into specialized tuning to be able to pull down that data and analyze it. Some additional things you may have seen when we were running we were running AC Hunter. Let's go to this one. I think it was this one right here. It was seeing user agent strings right down here. And basically, it had a unique user agent string. This gets into something that we do called prevalence. So a lot of malware will try to create a user agent string for its C2 beaconing, and they try to match what a normal user agent string is, but they may not get it perfectly right. Whereas, let's say we got 1,000 systems. All these systems have up-to-date Microsoft Edge and Google Chrome. You're going to see a lot of those user agent strings. But if you have one workstation and it's the only system that's using that specific user agent string, that kind of makes you go, huh, I wonder why that is. Now, in this particular situation, it is the malware. There's only one host that is going out to DigitalOcean that is using this specific user agent string. And that's the system that we would naturally want to investigate as well. Jaw 3, Jaw 3, I need to update this. It's now Jaw 4 and Jaw 4 Plus. But whenever you connect a TLS SSL connection that's out there, it's going to have a unique fingerprint associated with that for a number of different services, like update services for Microsoft, triggering bits, background intelligent transfer service, and those things. So we can look at those user agent strings, of course, but we can also look at the fingerprinting of that TLS SSL connection using Jaw 3, Jaw 4, Jaw 4 Plus to be able to make a determination of that malware as well. Now, ultimately, we're looking for needles in haystacks, right? I think that is kind of the point that we're trying to get across. We're looking for rareness, right? So there's fathead and long tail. If we look at an environment, fathead would be people going to Google. Fathead would be people going to Office 365. Long tail would be like SCADA ICS systems beaconing back. Long tail would be that malware because it would be rare in your environment. So we're going to, like, when we're looking at this, what this allows us to do is to break up this needle in a haystack. And I want you to imagine literally looking for a needle in a haystack and a tool that automatically sorts everything in the haystack by length, right? We know the rough size of a needle, so we can go down to that, right? So we're trying to break away what is normal that we would see lots of, which would be fathead analysis, and what is rare. What is the unique things that we see in the environment, which is long tail. We have denialist integration where we can see if there's any systems that are communicating on the internet that are denialist. So I can show you kind of what this does. Go to Shodan. Not going to do. All right. I'm not going to do SCADA. Let's do Mongo. Here we go. All right. So if you look at all these Mongo databases, we got Database Cloud, we got a database. These are all exposed directly to the internet. But this one is end of life. That means it's behind on its patches and it's from Wuhan. That's how we got COVID. It was a compromised Mongo database. All right. End of life cloud database. Let me keep going. I'm going to try to find something compromised because with my current account, we have an enterprise license, but I don't have it. We can look at some of these, and I'll just load up this one in India. There we go. So if you look at these databases, we have the ports. Perfect. This is exactly what I was looking for. The other thing that we can do is instead of looking at it from the perspective of, is it on a deny list, right? In this particular one, we have this server that's in China, and these are all the vulnerabilities that are publicly exposed to it, right? We have some 7.5s. If I keep scrolling, here we got some criticals, 9.8 Apache vulnerability, 9.1, 9.8. Do you want any of your computer systems talking to this computer in China? Like, take China off the table. Let's say it's not Wuhan. Let's say it's Kentucky. Let's say it's Belarus. Let's say it's, Brussels, wherever, right? Wherever it is, regardless of where it is, Is this a system you want any of your computers talking to? He just said, yep, Wuhan. All right. No, never mind. Being facetious, right? No, you don't want any of your computers that are communicating out on the internet with a computer that has a CVE of 9.8. Like that is remotely exploitable stuff right there. Okay. What are some other ones we have? Inconsistent interpretation. We have some really critical vulnerabilities on this computer. All right, let's take vulnerabilities off the plate. What about this? Look at this, you guys. What is this crap? Here we have this system. Of course, it's DigitalOcean, right? But look at all of the ports that are open. I'm actually going to go to port 80 because what the hell? All right, 404 not found. Let me go to 443. Let's see if we can figure out what the hell this thing is. I totally trust this system. Let's do this. Yeah, it doesn't like that either. But look at all the ports that are open. Like that's insane. Even the fact that it has port 2222. Why? It's got Grafana. This is like a front end management interface for databases, right? So we use this on Elastic. It's got a Grafana instance running on Mongo, which is normal. Oh, great. Look at this. It has Grafana set up. It has our shared dashboards. I don't know if I need to log in. Yeah, we got log in. I wonder what the default creds are, right? But once again, is this a computer you want anybody in your system talking about? Or talking to, rather? No. So when we're looking at this idea of denialist, we can extrapolate and expand the idea of denialist to be able to look at it from the perspective of, is this a bad system, right? Is this a bad egg that we're talking to as well? Now, all of this can be installed as well on Security Onion by Doug Burks. It actually really just rocks, and it's better than a lot of the commercial tools that are out there today. And we did the lab Zeek Rita. So let's talk about user entity behavioral analytics. And then you guessed it, another lab. That's all we got, just labs. Tons of labs out here. All right. So MITRE and UEBA, EDR, and like you were talking about things like CrowdStrike or Lima Charlie or any of those, they take out a tremendous amount of the MITRE attack technique matrix. UEBA, as far as baselining and like we could probably even replace this now with just AI. It's weird because like 5 years ago, AI was snake oil. Anyone that was talking about AI was trying to sell you crap. AI kind of came along in a big way, especially in the last 40, 45 days. And probably need to update this from user entity behavioral analytics and just move it to straight AI. And we'll talk about how AI is trained. So baselining and understanding what is normal traffic patterns for logs, for network traffic is what AI does, right? And logs, to be blunt, are a flippin' train wreck, right? There's no you've been hacked log that exists. And traditional Windows logs don't log useful data for security. You know, an example, changing a security policy. That to do that, you have to invoke privilege use, then you make a change, and then it shows the system account made that change. It's insane. It's not good, is what I'm trying to say. It's the opposite of good. It's bad, right? It's log, log, log. All right. So we're talking about logs and percentages, and really, Linux logs aren't that much better. Okay. It's just not the best, right? So going a ways back to JP a bunch of folks in Japan, they had this novel idea. They were going to run attacks using living off the land command execution, using tools like psexec, WMIC, scheduled tasks, beginx, WinRM, WinRS, and bits. And then they were going to look at what the impact was on the compromised computer system. What would be the evidence? What would be the logs? What would be the prefetch files? What would be the registry keys associated with that being used? And it actually was kind of revolutionary, right? It changed the way we looked at defense to really kind of have an offensive informing defensive approach to computer security. So why UEBA? Well, if we look at behaviors of attacks and how they're reflected in the logs, many times these logs will not be just you've been hacked. It's going to be multiple logs spread across multiple different systems. We got Active Directory, we've got Exchange, we've got OL. All of these things come together and they tell us a story. And in many situations, it requires us to tune our logs properly. So if we look at an example of an internal password sway, we have one ID accessing multiple systems very quickly. And this is what it looks like visualized. And this is visualized by Logon Tracer. There's a lot of tools that do this. I like this one because it's free. And it does this visualization on the event IDs that you see up here: 4624, 4625, 4768, 4769, 4776. And you can see that we have the SVC white noise account is logged into all of these green triangles simultaneously. That's not normal. That should not be something that we see very often in any sane environment unless it's a dedicated service account. And this leads us into the concept of log or detection tuning, right? I don't like the phrase false positives. I hate it. It's a detection tuning opportunity. We go through and we tune our alerts to be able to put in exceptions for things like SVC white noise. So as I said, not a thing. False positives don't exist. We have to go in and tune them. Now, the reason why I don't like them being called false positives is because if we allow them to be called false positives, what happens is users gravitate towards simply shutting off the alert. So if it's generating a lot of noise, they'll just go through and shut it off and walk away. And that is an incorrect approach to trying to deal with these types of things. Whereas rather, we need to go through and tune out things like SVC white noise if it's legitimate in our environment as well. We're looking for those things like, service accounts, help desk, systems administrators, scripts, and backup. And it's all about tuning because that is our job. Now, you may think that AI is going to save us. AI is going to help. I haven't talked much about it. I'll probably talk more about it and Ask Me Anything at the end of the session today. But really, when we look at AI and we talk about tuning, it can help, right? But it still needs a human in the loop to be able to make sense of what it's actually doing. Like I said, ask me about this and Ask Me Anything, and I'll give you kind of my soapbox breakdown of it as well. So how does AI and UEBA actually work for log analysis? One way it works is by stacking. And literally, I want you to think of stacking cards. So if a user logs onto a system, there's a +1 card. If they log off, there's a -1 card. And let's say we set a threshold. Users normally only access, let's say, 6 systems. We set that as a threshold. And then somebody shows up and runs Bloodhound. Now all of a sudden you have a system in your environment that is logging on to +2000. It's 2000 and climbing. Yeah, that's abnormal, right? We baseline what is normal for people logging into a system, and you could do this on a per user basis, which is what most AI tools do. And if all of a sudden you have the Edward Snowden account is now pulling down, a terabyte of data off a classified server, it's like, huh, he didn't do that yesterday or the day before or the day before or the day before. We might want to talk to this Edward fella and see what's actually going on. Other way, when we're talking about AI, is that learning, right? Going through and learning and baselining what is normal for each user. So Bob logs into 3 systems. Now all of a sudden, Bob's logging into 40. That's abnormal. We have to baseline what is normal. He normally pulls 3 meg, 30 meg. Now all of a sudden he's pulling 3 gig. That's weird. We're gonna have to sit around and have a conversation. What about Bob? Baby steps, baby steps. So next, when we're talking about this, we have to ask, where are our logs? We need to find them. We need to pull all of them. Servers, systems, network logs, log, rolls downstairs, bubbles and cares, runs over the neighbor's dog. It's log, it's log. Although the guy that came up with Ren and Stimpy was creepy as hell, which I find hilarious because even growing up in the Ren and Stimpy era, people that would watch it with me, if they were stoned or otherwise, would be like, whoever came up with this show was messed up. Turns out he was really a bad person. Who knew, right? So getting the right log is really a pain in the ass. And we're going to get into adversarial emulation here a little bit later. And we'll talk about this, and getting those logs becomes critically important. Active Directory, time to start tying that account activity into actual intelligent data, right? UEBA can help us. And a lot of people say AI and UEBA is incredibly noisy, but yes, security is hard. And I always say, it's harder doing this without UEBA or AI. So how long does it establish a baseline? A lot of the vendors out there, they would like to collect about a week's worth of logs, and they can do it retroactively. So they can process a previous week, establish that as the baseline, then move forward. And a lot of the AI stuff is getting a lot better at this as well. It used to be much worse, like a month. Now they're running it a lot cleaner. Logon tracer, once again, as an example, if you have the right logs, we can do data visualizations, right? We have this account that's logged into these three computer systems, and these users are logged into those computer systems. It helps us visualize the attack paths and the paths of what's going on in our environment. Also doing stacked ranking, which systems are logged into the most systems, which users are logged in to the most systems. Help us break that down. Time frame, super critical. Do you see right here where we start getting into 2022, 11, 11? We have these are the users that are logging into systems in the environment. And we have like this SG admin logged into 36 systems at hour 16. Maybe we want to investigate that. Maybe something happened in our environment right at this point in a heat map that is an anomaly in our environment as well. So this brings us to a couple of labs that we're going to be doing here in just a little bit. We're going to be doing a lab with Deep Blue CLI. Then we're going to use enterprise log analysis, and then we're going to play with Sysmon as well. So we'll be getting to all of that here in just a couple of seconds. So we have a lot of labs. We're not going to be able to do them all before close of business today. This is going to feed us into tomorrow because we're going to have a lot of logs of what we're going to do. So Deep Blue CLI helps us identify these patterns. And Deep Blue CLI is a stand-in for this class for UEBA. It's going to be doing pattern matching and recognition of anomalous log data. It's not necessarily an enterprise tool, even though we use it for triage for working incidents. Like we get the logs from the customer, we run it through. It's not something that you're going to run every day, but it articulates what different AI tools can do. Then we can do additional research. So here you can see it's telling us that we have multiple login accounts from one particular user, Bertha Schultz. So then I can do a quick little PowerShell script that I wrote up. It says, I want you to tell me all of the logins that we see from Bertha Schultz. And we can see all of those here. Deep White CLI is utilizing Sysmon, where it can look at that. We're going to get to that here in a bit. All right. So what we're going to do is we are going to do the Deep Blue CLI. Got to be honest, I hear Deep Blue CLI and I just think of the edge of the deep green sea. I think that's The Cure. Great song. Can't type. Wow. Let's do that. There. That's better. All right. So I am going to go into Intro Labs, Intro Class Files, Navigation, and we're going to do Deep Blue CLI right here. So let's go to Deep Blue CLI. And pretty quick lab, right? You're going to go in, you're going to run Deep Blue CLI master, set the execution policy. Nope, I don't want to do this lab. Screw it. We're doing this one instead. We are going to do enterprise or domain log review. This one. Here we go. Sorry. I'm getting my classes screwed up. So I'm going to paste this in. This is the lab that we are going to be doing. Sorry, everybody, for moving in the wrong direction. So we're going to do domain log review. So you're going to run Deep Blue CLI against a password spray log file. Then you're going to open up that log file in the Deep Blue CLI. And this is important because if you don't open the right logs, this lab gets really confusing. You want to make sure you're opening DC2 sec logs domain password spray. There's domain password spray DC1, app logs, DC2, app logs, and set logs. We're looking specifically at DC2 sec logs. Make sure you're pulling down the right one. And when you open it, it's not going to open the right place. It's going to open up probably Sysmon operational. You got to scroll down after you double click it. It's not going to open to the right place. You're going to have to scroll down and open up saved logs to open up that password spray. Then you're going to sort on event ID, and then you're going to look at the event ID 4776, and then you'll see the names of all the people that were attempted to be logged into. So this is the lab that we're going to do. It's going to take us, let's go ahead and let's give it 30 minutes because I didn't allow you guys to take a break. Sorry for pushing you all on that. So 10 minutes for a break. 20 minutes for the lab, then I'll do the walkthrough, and then we're just going to jump right into Sysmon. So let's get rolling. If you need anything, hit us up. Here we go. You guys would laugh at my makeshift. I don't have my iPad for my Discord stuff because I see you all over here chat. Like this is where you are, right? And by the way, the shirt that I am wearing, people were talking about the shirts. For some of you, you got shirts. This is the if we can let me do a screen share with that and let me explain this shirt because I like things that I have to explain that I think are cool. So right here, this is the shirt that was created. So I want to give you a breakdown of the idea that I had with it, and then you can see kind of what Daniel, our main t-shirt designer, did with it. So let's kind of ask some questions, and then we're going to get into the lab, and then we'll get into another lab here in just a couple of moments. But we have this apple now. Normally, whenever you see this apple, it's golden, and we're setting up levels of people within Discord where you'll get like a white shirt, a silver, or a gold apple. And a gold apple is the highest one available. Does anyone know what the symbolism is associated with a golden apple? We got some people that are typing things. This is my display name is typing. It's a golden apple. We got a bunch of people that are going after the apple. Greek mythology, it absolutely is Greek mythology. So the Greek mythology specifically relating to what? Greek mythology with what? So got several people typing. Yep, it is the Trojan War. So a golden apple was thrown into a room and it had written on it Callisti. K. It was a golden apple with K or Callisti, and that is Greek for the most beautiful. So this apple got thrown in with a bunch of goddesses, and it was designated for the most beautiful. Turns out it was none of the goddesses. It was a human, and that's literally the jealousy over this golden apple is what kicked off the entirety of the Trojan War. Now, the idea of a golden apple with a K in the middle is a symbol for precipitated discordia. So what that means is like just discord, right? It's chaos, right? And so it's used for the Illuminati and things like that. But if you look, you can see that it doesn't have a K. What it actually has is a transistor symbol here in the middle that looks an awful lot like a K. So a transistor has three different parts at its root. It has a base, and our base is Black Hills Information Security, a collector, which is active countermeasures, and an emitter, which is Antisyphon. Antisyphon emits training. We collect data and packets with active countermeasures, and the base is Black Hills Information Security. So the root of our Discord, as the K for Callisti, is a transistor. And the root of our Discord in the community in the world today is people trying to own the concept of the transistor. So that is the stuff behind this particular shirt. Also, as I said, this is a representation and a symbol of Discord, and it is our shirt that we advertise our Discord server on. So I like lots and lots of layers and meaning and all kinds of like crazy things. But this is one of my favorite shirts that we've created. So hopefully you all get a chance to go and get one of these shirts. All right. So let's go through this lab really, really fast. So we did domain log review. So I am in my VM. I'm going to go ahead and close this session and I can open up a command prompt. There we go. And I am going to CD. I've got to open up a PowerShell prompt. Let's get the right prompt, the right job needs the right tool. So we're going to move into the Intro Labs Deep Blue CLI master. And then we're going to run int logs dc2 sec logs domain password spray. We're going to analyze a password spray. Now, this takes a few moments for Deep Blue CLI to be able to analyze this. So you can see here we have, failed login accounts. We have 232 accounts and 240 failed login attempts, and that is a lot. So this would be the equivalent of AI or UEBA looking at our logs and saying, hey, there's some type of shenanigans going on here as well. So now I can go into Event Viewer, and then once I'm in Event Viewer, we can go down and we can look at the saved logs that we have opened up. So I have DC2. Nope, I don't have those ones yet. So let's go ahead and let's open up those event logs. So I'm going to go to C. We're going to go to Intralab, Deep Blue CLI master, ent logs, and then we're going to go to DC2 sec log domain password spray. Double click that. Opens it up. Okay, here we go. And then we have DC2 sec logs. And now we have our event log. So if I sort by event ID like this, and I go down to the bottom, I'll be able to see all of these credential validations. Now, these specific event IDs are different than the ones that Deep Blue CLI was looking at, but we're looking at these event logs because it's giving me the names, right? And it's giving me the machine for the source login. So you can see we have Samantha Ryan. Somebody tried to log in and failed to do so as Samantha, as Roderick, Sir Roderick, Timmy. We're going to need another Timmy. We Vernice, Kyle, Jackie, Sylvia, Jody, Corey, Nancy. We have all these credential validations, and if you're looking at the time frame around all of these, it's very, very, very tight, like within the same second. For these particular logs being logged, you can see that we got 7/20/14, very high rate of speed. This is a password spray. It happened that fast. The other thing that it's telling us is it's telling us this is the source workstation. So this would be the workstation that we'd want to investigate to be able to do this. So we've got Andy had a question. Code should be flags at the end of the lab. That is what is coming up. During the next lab, I'm going to go through and get my system set up, and I'm going to show you competitive backdoors and breaches, Andy, because I'm going to blow your mind. It's going to be crazy what we're going to do. But the point is, we're creating a competitive card game, and in order for you to get the cards to play competitively in one type of competition, you actually have to do a CTF challenge, get a code, and redeem that code for the card. So that's really, really super cool stuff. All right, so let's go a little bit longer. We've got adventures and logging. So logs are bad in Windows. I don't know of any other way to try to put this and try to sugarcoat it. We're just going to go with bad. Okay. We have all of these event IDs for login, log off. These are some of the core event IDs that you should be looking for. And it's really hard, like, to be able to fully detect malware with each of these different types of logs that exist in an environment. So then we get into a question, because yes, I know the power of a question, because there'll be no shelter here. The front line is everywhere, which, by the way, one of Rage Against the Machine's best songs, No Shelter, it was on the Godzilla soundtrack. And it's a very heavy hitting video, and it's hard to find these days, but it's great if you look at it. So one of the questions that I like to ask, because I know the power of a question, is how much do you log? Right. So many organizations, they look at their security support structure in terms of we're logging, a terabyte. That's great. Awesome. Some organizations are logging a petabyte. The largest SOC customer that we have at Black Hills Information Security logs 1 petabyte of logs a day. That's a lot of logs. It's a lot. So is that a bearing point for how security, like how well security is implemented? Probably not. A better question would be what percentage of your logs have an alert, a signature, or a rule written for them? And the answer to that question is a lot more difficult. In most organizations, it's right around 5%. Some organizations, it's up to around 10% because they're doing some tuning. At BHIS, it's probably closer to 70% because we very, very, very carefully prune out logs that don't have alerts or signatures associated with them at all. See, the problem is in the industry that logging is determined by a lot of different government agencies and compliance standards groups. And when they come up with logging standards, they try to get logging experts. And the logging experts that they get are people from logging vendors, thinking that the vendors themselves are the experts because they do this. And the answer from the logging vendors is always more. And they always say more because that's how they make money. And that is what we call a perverse incentive. Right? So I want to show you something basic, something simple to set up the next lab that we're going to do. If let's say I want to do command line logging, let's say I wanted to log on a Windows computer system. Let me show you something real quick. If I go into Windows logs and I go into the security logs on a Windows computer system, right? I have these logs that have like special logon success, and they're really not all that powerful because the way Microsoft logs, is very much like if I try to do something that's an admin level thing, I invoke privilege use as my account, but the actual work that's being done is being done by system as an example, right? So you have all of these things, and you get these things. This event is generated when a logon is destroyed. It may be positively correlated with a logon event using a logon ID value. Logon IDs are only unique between reboots on the same. So much cocaine went into this. Like if you're looking at Microsoft and them developing their logging strategy, so much cocaine went into this. And I didn't get a chance to do the full story, but I'll do a little bit of it now. If you ever wonder like how much cocaine, all the cocaine, if you do Bill Gates' desk, right? I got a picture of him laying on a desk like right here. Like that is a special picture, right? There he is at the Microsoft headquarters right now, sitting on his desk, right? Some people will be looking at this and they'll be like, that's strange. I thought it would be an island in the Virgin Islands that he'd be hanging out with. This is before all of that, right? So this is him hanging out at his desk in Microsoft, right? And in the background, you can see all this white powder. That's cocaine. It's a lot of cocaine. Also in Discord, you see a lot of people posting pictures of Steve Ballmer, lots of armpit sweat and a lot of activity. Developers, 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 right? Like lots of cocaine. And I want to show you what cocaine gives us. Like if you're just doing pure cocaine, you get event logs like this that give you little to no information about what is actually valuable, right? If I go to the application event logs and I ask you, what should the application event logs log, right? I'm just going to ask you that simple question. We're going to put it on the table. There's no wrong answers, right? Just creative solutions. If you were going to create the application event log in a Microsoft Windows system, what would you log? If it's an application event log, what would you log? If you were going to log in the application event logs, it's got several people typing logs, applications, right? You would log applications starting, like they opened Microsoft Word, they ran a command, they did these things. We would log that. Nay, nay, that is not what happened here. What happened here was cocaine, and then this came out, right? So if you look at this, we have this security SSP. The successfully scheduled software protection service restarted happened at this point, and the reason? Rules engine. What the hell does that mean? No clue, right? You may think it's your AV. It's not. It's not. What about this? Offline down level migration succeeded. Okay, right? We got CAPI, successful auto update third party root list with effective date of Tuesday, August 26, which is in the past, right? Successful auto update third party root certificate. Okay, well, this is at least a certificate. Starfield Technologies, that's helpful, right? This is insane. This is little to no value, and it's not what you're looking for. Look at this one. SVC host, the database engine attached database, Windows 32, config, profile, app data, storage, DS token, DB2, time 0 seconds. It doesn't see me running malware. If you run your malware, it's not going to create an event here. You're literally not going to get the events. These are not the events that you're looking for. This one, Edge update, service stopped. Which service? Was it Edge update? Why did it stop? Did it stop successfully? Did it stop unsuccessfully? Who knows? All we know is it stopped. That's it. So this is insanity, right? This is absolute insanity. This is insanity. If I wanted to turn on command line logging, you'd think that we'd be logging command line activities as part of standard logging in Windows. No, no effing way. We aren't going to do that because that would be sane and sober, right? So to do this, and I don't expect you to memorize this, I do this just because it's funny. To do this, following these instructions, you must have audit process creation auditing enabled. You must enable the policy setting to include command line and process creation events. You get this warning. And it says, when you use advanced audit policy configuration settings, you need to confirm that these settings are not overwritten by basic audit policy settings. We're not done. To max log file is going to be small. We need to increase it. We need to turn it up. To see the effects of this update, you will need to enable 2 additional policy settings: admin template, system audit process creation, policies, Windows security, advanced audit, detail tracking. And yes, the second setting will most likely be overwritten by group policy. Then, to avoid that overriding of the advanced audit policy settings, a third setting is required into the definition domain policy, computer security, local security audit. You have to enable force audit policy subcategory settings to be enabled as well. And when you do all of that, you get command line logging. Oh, that's beautiful. That's crazy. But what about PowerShell? PowerShell, you have to run six, or what is it? One, two, three, four, five, six. Six commands in order to get PowerShell logging working. Now, you can absolutely put it into a script. Why, Roswell, UK? Cocaine. That is literally why I set up the whole cocaine thing, because it is the only sane reason to me on how this actually happens. Okay? We have all these PowerShell settings to get it work, and when it works, it works. It's pretty cool. Or, and I'm just throwing this out there as a crazy idea, we could use Sysmon. Sysmon was created by Mark Rusanovich, who I am pretty sure was not on cocaine. At least he wasn't initially. And around 2019 is really when he started looking into this and pushing it out. And you started seeing companies starting adopting this widespread. It takes like 10 seconds to install Sysmon. And when you get Sysmon, you get the Sysmon operational logs, you get this. Program starts, you get the name of the program, get the directory of where that program started from, file version, original name and description. You have the parent process. You get the hashes. You get the hashes. You can put your hashes in there, man, as well. So can you track code that came in through WinRM that's base 64? Yes, you can. In fact, you might see that in the next lab that's coming up here in just a little bit. So you can push it out with group policy, and you can pull these logs off of WinLogB. And that's going to take us to the next lab. That's going to take us 20 minutes. So let me go into intro class files. I've got to clear off the Bill Gates out of my computer. Ew. Ick. Bill Gates. There we go. For the record, I used to like Bill Gates, by the way. I did. I just want to make that clear. I did. So if anybody finds previous videos where I'm extolling the virtues of Bill Gates, that was before. And my favorite Bill Gates thing that he ever did was release a bunch of mosquitoes in a talk talking about wiping out malaria. And the room was filled with like billionaires, and everyone ran out screaming. That was pretty cool. But just because a guy does something cool doesn't mean that everything he does is cool. So, yeah. All right. Just clarifying, getting that out there. Don't want to get anybody all worked up. Not a Bill Gates fan. All right. So the lab that we're going to be doing here is the Sysmon lab right here. And we've got the techniques. We see this in the MITRE. We got technique 1078. These are some of the attack groups that use this. We're going to shut off the firewall. We're going to set the administrator password to password 1234. Then we're going to open up a Kali terminal. We're going to become REIT, and then we're going to mount over the Windows system. And then we're going to mount to share. You've already done this. You did this yesterday. We're creating malware. We're doing it again, but we're showing you how if we enable Sysmon on the computer system, we can get solid logs for that malware on this computer system, right? We actually get good event logs for it. All right. So with that, everybody, this is the lab. I'm going to put, let's put 30 minutes on for this one, Daryl. And let's let people roll through it, and then I'll do the walkthrough tomorrow morning. How does that sound, everybody? And then we'll do Ask Me Anything for the last 20 minutes of class. Let's get to it. question. Hold
Yeah,
on.
what's up? Good.
Hi, everybody. So, currently up on my screen, I have competitive backdoors and breaches, the online version of competitive backdoors and breaches. And here with me is Tim. Tim, say hi.
Hello, everyone.
And we're going to be playing a game here in just a couple of seconds. Now, while we're doing this, let me try to move over to Discord. This will be coming out probably in the next 45 days or so. But some people were talking about how are you going to build this up here in a little bit for like when you're doing a lab and getting CTF, and how can we make that into a game and something that you can have with it. So we're showing you right now, it's not even alpha, right? Like it's pre-alpha, but there's nothing like demonstrating a pre-alpha product to 75 people on Zoom and God knows how many people on the wider YouTubes. So the first thing that you do is you create your deck of competitive cards. These are prep cards, and the game will take you through. And we have physical variations of these cards, and you can buy them in the Spearfish General Store. But they're prep cards that are set up for the game that introduce scenarios and allow you to like power up your turn. So I've gone through and selected 14. I've got to choose my last one. I'm going to choose. Oh man, I don't know. Tim, what do you like better? Theft and resale of trade secrets where you just get 2 resource points, or today I RTFM'd?
I always like buying a detection for free. I think it's really good when you play the game.
Yeah.
So I recommend today we RTFM.
All right. So now I have built my deck. All right. So this is set up to be a deck building competitive game, and the strategy comes with you building your deck in this game. So pretty cool stuff. I'm going to, wow, Discord blew up. There we go. All right. So now I've got my deck. I am going to go play. I'm going to go to the game lobby. And I have Tim versus John. So I'm going to join as a spectator right here. Or join as a player. I'm joining as a player. Sorry. There we go. I'm now in the lobby. I've got my deck. I'm going to choose my submitted deck. And now I am ready. My deck's ready. Tim's deck's ready. And I'm going to send a chat to Tim. Let's go ahead. I'm going to roll for initiative.
I'm going to roll for initiative.
God damn you. I'm gonna do some trash talking here because I rolled a 6 and he rolled a 20, and he gets to go first. Now I am watching him play his game right now. So Tim, do you want to talk us through what you're doing?
Yeah, so the first thing in my turn every time is I'm going to get to draw 3 of my 15 cards that we built our decks with. So I'm going to go ahead and click that little area that's glowing blue. And it's going to randomly draw 3 of those cards. And I'm going to look through them. Now, from your guys' point of view, you're not going to be able to see them, but I'm able to see them. And I'm going to pick one that I want to do. So I'm going to say, I think I'm going to pick venture capital funding is in. I need a 13 or better to activate this card. So I'm going to get to roll for it. I rolled a 13. There we go. So I get 4 RP from the bank, and I will get +1 action that I will use when I get to the action phase of my turn.
Dude, the cards, that sucks. I hate you. All right. So now you get to move to an action phase, right? You can go to the market, buy defensive cards, or
So I get to go first to my market if I want, and I could buy something. I'm not going to because I'm going first and I'm not under attack. So I'm just going to hit my skip purchase phase button. And then now I'm on my attack phase and, or my action phase, and I'm not needing to defend. So I'm going to attack you. So I'm going to go ahead and roll for that.
Ooh, and it's successful. If it's over 10, folks, 11 or higher, then it's successful. Now, what happens when you roll successfully, Tim?
When I roll successfully, I'm going to start building my kill chain. And once I get my kill chain full, I'm actually going to be able to steal your RP.
Yeah.
If I wipe you out of RP first, I win the game. So I failed my second roll, but if you remember the card I activated, I actually get an additional attack action. So I basically get a reroll here. So I'm going to go ahead and use that.
Critical failure.
I actually crit, and my turn is over, and my attacks are now off of you.
Yep. All right, so now it's my turn, and to help guide me, I have my blue deck down here, glowing blue. It's going to draw your attention. This is where you need to click. And I'm going to click, and I'm going to choose out of the 3 cards that I have. Um, I um, I have AC Hunter. This is a trap card. I'll talk about that more here in just a little bit. I'm going to go right straight into no detects, right? I'm going to try to roll for this one, and I got to roll 9 or higher. And then that gives me +1 on my attack action. So it helps me with my roll. So I'm going to roll my dice, and I got an 18. So now that means I get a +1 on my card. All right. So we've got that. It's activated. And now I'm going to skip the market. I can click this and I can just go through and just skip purchase. I don't want to purchase any defensive cards. Now, whenever I purchase a defensive card, it adds a +3 to that defensive card's power. So basically, instead of like a 10 or higher, I can roll like a 7 or higher. But I'm going to skip this because I'm all about the offense. So I'm going to go to my initial compromise. We're going to roll for that. And I get a +1. So I've got to roll for that. 20. That is a critical success. So what a critical success means is I just completed my attack kill chain. When I get a +20, I now get to immediately start rolling for Tim's money. If you look over here, you can see it's kind of faded out. You can see I now have 4 cards as part of that attack chain, and it's just set up. Now when I click this dice, I'm stealing money. And anything over 10 allows me to steal money from Tim. So 11 is 1, 12 is 2, 13 is 3, and so on. So let's roll. And I rolled a 2. So I take no money from Tim, but I get to roll, right? Because I get to do that. So I'm going to re-roll that. It still sucks. I'm happy with where I'm at though, Tim. I'm going to hand it off to you.
Yeah, for demo purposes, that's a good thing to show. So I'm in a little bit of a pickle right here. So I'm gonna probably play on a little bit more defensively. And I actually just drew the Today We Are TFM card that we talked about earlier that allows me to buy a defensive card or a detection card for no cost. So I'm gonna probably want to try to play that one. And lucky me, I got it. So I'm gonna go ahead and get to purchase something for free. And on my screen, you guys again can't see this, but I get to see what is most applicable to the kill chain that John has against me. So I'm going to go ahead and buy something. And because that was part of my first phase, I could technically make another purchase here, but I'm not going to because I like stockpiling my health or my RP. So I'm going to skip my actual purchase and go into defending. So when I defend, I'm going to click my detection card, and I can go ahead and roll to defend against.
Oh, god damn. Oh.
So I knock one off, and it still is applicable to some of the attacks in the kill chain. So I get to keep rolling until they don't apply to anything. So there's another one, and I think I get one more because it applies to 3. This is a great defending round. This is fantastic.
Yeah, it's great. I'm happy for you. Well done, Tim.
I think that I think that we are still working out some bugs, but in that instance, I just defended there, and it knocks off the kill chain.
All right, so I'm going to go back to my prep cards, and I'm just going to pull in 1 detection card at no cost. I'm going to confirm that. Let's roll. And I got a 15, so now I get to choose a defense card. And I am going to choose. I'm going to go with endpoint protection analysis and do that. So I just bought that card. I don't need to get any more market cards, so I'm just going to skip. I'm going to go down to the bottom and skip purchase because I want to keep those resources in play. And now I'm going to go back on the offense again. So now we're going to roll. And I got 1 on the board. So initial attack, because I'm successful, I get to roll again. And I got another success. So I got my persistence. And I'm going to roll again. Oh, critical fail. I got wiped out again. Why? Why?
You can't play against him, it seems
That's
like.
what I think that Tim set us up the bomb
Maybe.
here.
And this, I didn't enable that command.
The Tim always wins command. Is that the
Yeah.
cheat code?
Yeah, I didn't enable that one. But
I was going for executives get it.
I did get it.
Got it.
So this one gives me an RP from the bank. It's also going to give me an extra purchase action and then another like either attack or defend action. So it's a pretty good card. And if you guys can see now, you guys should be able to see that detection card that I used to defend last turn is in a cooldown phase. So I actually can't use that if I needed to this turn. I would have to wait 2 turns for that timer to decrease. So I'm going to go ahead and skip my purchase phase. We'll see.
Back on the board.
On the board.
Oh,
No,
mm.
that's a crit.
Now he's gonna steal my money.
Does give me an extra reroll. And I rolled another 4.
All right. Steal failed. All right. So now it's my turn. All righty. So we are going to go straight to my prep deck. I'm going to go CTO on ketamine, and I'm going to get 2 resource points because I think I might be needing that. And I'm going to get 1 action. But to do that, I have to roll 11 or higher. 16, I got it. So I get an extra action. And that card is activated, which is very cool. And I got 2 extra resource points to my name. All right, so I'm going to go to market. I'm going to skip market because it's all about the offense for me. And I'm going to roll for offense. Critical fail. That's great. It's awesome, Tim. Why are the dice going to 1s and 20s so much? I've never seen this.
Really good. Yeah.
Yeah. So
Yeah. I actually think that the digital dice is probably more consistent than actual dice.
it would have to be. It would have to be. It would have to be. Oh no. Oh no. Yeah. All right.
I didn't get to steal 4 RP from you.
Yeah.
So, oh well.
All right. So what are we doing next here?
I'm stealing from you. I'm stealing your RP. Hoping for that 20. Nope, a 7. Dang it.
Oh,
Just need to steal some of that money.
some of that. So you can't roll a 20 when you really need it, right? So let's go ahead. Let's go to our prep cards. I'm gonna do single pane of glass to basically neutralize one of your defense cards. It's now neutralized.
Oh,
There we
that's a
go.
good card.
All right. And I'm going straight into the attack. I've got to go to market. There we go. Here we are. Let's go to initial compromise. And we are froze. It might be my VPN. All right, but at any rate, we're kind of at the end of class, but I just wanted to show you guys what we're working on. I had promised this to you yesterday, and I'm getting close to losing. So this is a way for me to kind of, I guess save some face, I suppose, about what's going on. But I hope that you like it. And I am really, really, really excited about the game and kind of what we're doing with it. And we're going to hopefully have this out in the next 45 days for everybody. But the game, the actual physical instantiation of the game, I believe it's for sale in the Spearfish General Store. Is that right, Tim?
Yep, it is.
Yep.
And we just actually got all of the rest of the decks in today. So
And
we have them.
we had a question.
Yeah.
Shannon said, how many people can play at the same time? Usually we play about 4. However, I've seen games where 6 people have been playing against each other. So you're defending and attacking against everybody on the table, and you just kind of whittle it down. So it's made our competitions a lot more fun when we do like tournaments and stuff. So I was really excited, Tim. I don't know about you, but Wild West Hacking Fest in Denver, I think it was like 10 o'clock at night, there was still a whole bunch of people that were down in the conference area, and they were actively playing, which was really, really super cool to see
Yeah.
that. So I was excited to see it kind of take off as well. So, alrighty. So that's what I got. We'll do Ask Me Anything tomorrow. I just wanted to show this to you. And by the way, how this fits into the broader thing is eventually, not now because it's different phases, but eventually there's going to be a tournament style that's going to be like the hardcore tournament, or we'll call it the elite tournament, 1337 tournament. And what happens is if you want a phishing card, you're going to have to do a phishing CTF challenge and solve a phishing CTF challenge. If you want a malicious browser plugin, you're going to have to do a malicious browser plugin CTF challenges. So you'll literally have to earn your cards by doing labs and CTFs so that you understand what that card actually does. So if you're playing it in elite tournament, it's going to be something where that person, you might have a much smaller deck because you don't have as many attacks and detects in play because you haven't learned those skills. So that's some of the stuff that we're working on down the line. But the first thing is getting it set up so people can play against each other competitively. And then the second thing is getting AI so you can play by yourself against a computer. And then finally getting it to the point where we can put in like the elite competitive. And there's so much stuff that we have planned and Tim's working on. So, give Tim a round of applause.
Yay,
For kind of what he's
Tim.
put together on the team. And what's the name of our developer that's working on this as well? Make sure that he gets credit as well.
Yeah, his name is Adrian, and he's doing
Adrian.
fantastic work. He started on this, everybody, last Tuesday. I just want to put that into perspective. So he is absolutely killing it. Really happy with everything that he's been helping with. And yeah, like John said, we have a bunch of really cool stuff, planned. So stay tuned.
All right. And with that, let's shut it down. I'll see you all tomorrow and we'll do that walkthrough. Take care.
All right. Have a good night, everybody. I will be back on tomorrow at around 12. And sorry I missed you guys today. I'm glad I got to join and see the end of class. But with that, go ahead, Daryl. It's time to kill it with fire. Have a good night, everybody.